Picture this for a second. Imagine a stunning, hyper-realistic view of Earth from space at night. Everything is normal. And then, suddenly, without a single sound or a massive explosion, the full moon just vanishes. It's completely gone. The sky instantly becomes noticeably darker, and our planet is just left sitting there, completely alone in the void. Okay, let's dive into this because it's a fascinating scenario rooted in actual planetary science. In this explainer, we're going to walk step by step through the dramatic, real-world cascade that this sudden absence would trigger across the globe. And we're going to look at exactly what happens when Earth's constant companion literally vanishes into thin air. The contrast we'd be dealing with is just absolutely stark. I mean, we'd go from the Earth we know and love, with brightly lit nights, massive ocean waves, and a beautifully stable planetary climate, to a world of pitch-black nights, eerily stilled oceans, and eventually violent weather extremes. It's kind of crazy to realize, but our closest neighbor in space is actually the hidden engine driving almost all of Earth's daily rhythms. To really grasp the sheer magnitude of this event, let's quickly map out the disaster on a timeline. At 0 seconds, the moon vanishes silently. Poof! Fast forward just 12 hours, and this extreme, unnatural darkness falls across the entire globe. Give it a month, and the world's churning oceans dramatically calm down. But jump ahead thousands of years, well, those immediate effects escalate into a massive existential threat as Earth's very tilt begins to destabilize. Let's start with the immediate impact right down on the ground. The absolute first thing you would notice is just the intense lack of light. Imagine standing in a suddenly pitch-black forest, or looking out at a city skyline that has completely lost that ambient bright moonlight. The familiar shadows are just gone, and everything is instantly swallowed up by a heavy, oppressive night. Now, what's really interesting about this slide is the dual reality of this sudden darkness. On one hand, yeah, without the moon's glare, the starry skies would suddenly become intensely, cinematically visible. But for life actually on the ground, it's immediate chaos. Nocturnal animals would instantly struggle to hunt, and basic navigation just becomes totally impossible for so many species simply because they rely heavily on that lunar glow to survive. Moving from the darklands out to the open water, we would witness an equally eerie transformation. Those massive churning waves we're so used to seeing crashing against the shores, they'd suddenly lose all their momentum, and the vast oceans would effectively begin to stall out. To understand why this happens, we had to look at the basic science of the hydrosphere. Lunar tides are the rhythmic rising and falling of our oceans, right? And they're driven primarily by the powerful gravitational pull of the moon. Without that lunar gravity physically tugging at our waters, the ocean's main engine is just fundamentally turned off. Let's move to and see how this builds across the globe. Step 1, lunar gravity just completely vanishes. Step 2, those huge ocean waves rapidly calm down. Step 3, coastlines everywhere suddenly experience drastically weaker tides. And finally, step 4, because of this severe lack of movement, shoreline ecosystems change permanently. You can almost picture a dramatic time-lapse of our coastlines just slowly transforming as the water settles into this weak, totally unrecognizable rhythm. And, this connects the stilled oceans directly back to the wildlife. It's a devastating butterfly effect. So many ecosystems depend intimately on the moon's cycles. Without it, marine life, terrestrial wildlife, and even human activities tied to the ocean would be thrown into complete disarray. Look at the specific victims here. You've got sea turtles, totally struggling to find their nesting beaches without the moonlight and the tidal cues they rely on. Birds would suddenly be forced to change their migration paths, completely thrown off their natural biological rhythms. And marine life cycles in general, utterly disrupted by the altered tides. It brilliantly illustrates just how deeply our planet's biology is tied to that celestial dance up above. But let's zoom out now. Let's look at this on a much grander planetary scale. Because beyond the struggling animals and the flattened oceans, there's an ultimate long-term catastrophe brewing up in the atmosphere. The Earth itself is now fundamentally off balance. To really grasp this climax, we have to talk about axial tilt. This is the precise angle of Earth's rotation that dictates all of our climates and our seasons. And what a lot of people don't realize is that this tilt is heavily stabilized by the moon's gravitational presence. The moon acts like a massive cosmic anchor. Without it, Earth would slowly begin to wobble out in space. So the crucial point is what actually happens as this wobble takes effect over thousands of years. Earth would slowly tilt off its axis, and our weather patterns would change drastically. We'd see the emergence of incredibly extreme global storms and intense heat and cold fluctuations just blanketing the globe. We're talking about terrifying weather extremes that humanity would have to somehow endure as the planet quite literally loses its balance. It brings us to a profoundly important reflection from our source material. Our closest neighbor in space plays a much bigger role than most people realize. You know, the moon might seem quiet. It might seem like just a distant, dead rock floating up there. But it is actually the unsung hero keeping our world entirely stable. Without it, Earth would never, ever be the same. Imagine Earth right now, completely alone in the dark void of space, with no moon floating beside it. As we slowly pull back and look at this final concept, it leaves us with one massive, lingering question to take away from this explainer. Could humanity survive and somehow adapt to a world without the moon?